and it will be posted to the Reynolds website later for anyone who wants to go back and listen to it again. And the slides will be available as well. So today I will be presenting myself, Brandon Singh. I'm a network specialist with the Reynolds Company out of Fort Worth. And I will also be joined by Joe Pileski, who is an automation specialist and network specialist for the Reynolds Company out of Houston. So some upcoming events that we have going on with the Reynolds Company. We have our users group tomorrow, which is a little bit longer than our Tech Talks. Tech Talks usually 25, 35 minutes. Our user groups usually run about an hour. Tomorrow we'll be discussing control objects redundancy. And then we have a couple more upcoming Tech Talks. We will have the final installment of the Industrial Network Tech Talks next Tuesday, the 23rd. And we'll be going over SIP security. And then on Wednesday, the 24th, we will have Bulletin 931 signal conditioner. And then Wednesday, the 1st, we will have automatic device recovery with PowerFlex drives. So again, the Tech Talks are a little bit shorter, 25 to 35 minutes, whereas our user groups usually go a little bit more in depth and run about an hour. So today we'll be discussing converged plant-wide Ethernet, CPWE, or Industry 4.0. Has very different terms, vernaculars. Essentially, it's a convergence of IT and OT into one segmented Ethernet for the plant floor. So this is today's agenda. We're going over a high-level overview with Cisco and Rockwell Automation Strategic Alliance, some challenges associated when implementing CPWE, and what it addresses as far as current plant structures, some customer feedback, some overview on the reference architectures for CPWE, some key tenets of CPWE architectures, and then some key takeaways. So Rockwell and Cisco joined this alliance together about 13 years ago, and over that time they've produced 15 different tested and validated architectural designs for CPWE within multiple disciplines to enable the OT and IT collaboration and convergence. So right now, there are a number of different market pressures that are putting productivity and profitability at risk for manufacturers. There have been rapid globalization, which opens up new opportunities. And through that, 87% of manufacturing executives report that aging infrastructure impacts their actual operations. And another significant challenge in today's market is the increasing number of security risks and threats. What's needed to modernize is a digital transformation. For example, aging infrastructure has resulted in proprietary networks and services that has increased network complexity, limited security, and the current network infrastructure has not always been robust enough to mitigate newer and more sophisticated security attacks. And on a scale and volume, data is ever increasing, and historically has been difficult to capture. So with that, what CPWE looks is to capitalize on all of those things for a digital transformation. Rockwell and Cisco, when they made their alliance about 13 years ago, it was to bring highly strategic and trusted domain experts in both IT and OT together. Rockwell Automation has a deep knowledge and expertise in OT, in the OT space, and their OT products are deployed as part of industrial operations infrastructure. And Cisco is a world leader in network and network security with a broad offering of production products themselves. And together they're able to bring those things to form a digital transformation through CPWE. So this diagram just kind of illustrates CPWE simplifies the network design by connecting industrial operations and business systems together in a way that is seamless and secure. These siloed networks of the past and the proprietary networks can now be integrated into converged plant-wide Ethernet architectures by providing greater real-time visibility into the state of the industrial operations. This connectivity is achieved through an open systems that adhere to regulatory standards, whether it be IEEE standards or ISA standards, all the different governing bodies. Um, it can be very flexible and scalable, and proprietary systems, as I said, can now be integrated without needing massive upgrades to save on the infrastructure costs. Now, there are some challenges in current network standards that CPWE helps address. And some of those, again, those siloed, isolated networks can now be more visible as a whole. It's flat and open and non-resilient automation and control system networks can now be brought in together and then be a little bit more secure. Now, open doesn't mean that it's going to be necessarily easy, and the standards doesn't mean it's going to be foolproof. By design, we're implementing these to make them more secure. So we'll be creating larger LANs that have less natural boundaries and natural segmentation, and smaller connected LANs created boundaries and segmentation through structured products and infrastructure, as well as security that is put in place. Now, we've all probably seen this diagram at some point or another in any different conversations regarding converged plant-wide Ethernet, whether it be online somewhere at different webinars or presentations that have been shown. The OT and IT collaboration that Cisco and Rockwell wanted to put together is basically sharing best practices for control system engineers and network engineers together by standardizing a design and technology, the different reference architectures. As I said, they've tested and validated over 15 different models and architectures, and they just want to put it together for an industry standard to help with the digital transformation moving forward. So on this, the bottom portion there gets highlighted because that bottom portion is generally where a lot of that convergence tends to lie on that model. It's where, your traditional network and Cisco side would be up toward the top and the yellow portion of this diagram. And the convergence all happens together through the middle. As we see highlighted here, industrial IT is what they would like to call it. Now, we do have some customer feedback from those who given feedback both to Rockwell and Cisco who have implemented these things and made a complete flip to a full CPWE standard. And a lot of them, like global consumer packaged goods, they helped with their own OT and IT convergence into industrial IT. It's proven architectures, as I said. They've all been tested and validated, so you don't have to worry about the validation process. If you're something like a pharmaceutical plant or someone who's regulated, has different regulations through FDA, these architectures have been proven, tested, and validated, and can be implemented. And then there's also the unique aspect of it. A lot of these older networks that we're trying to converge together are proprietary and have evolved and have grown, and some plants, are unique to themselves. So the goal is to collaborate and educate the staff on industrial Internet of Things and industrial IT and bring things together. CPWE does justified network and security projects, as the goal is to help secure the network in the long run as well. Together, Cisco and Rockwell, as I said, are leading that charge through digital transformation. It's enabling business agility and flexibility and scalability. It's optimizing production. As I said, you're able to see into those, you're now being able to see into those what were once siloed and segmented off isolated networks. It will now be able to be seen and be visible. And all while we're doing this, we want to minimize risk by putting in the correct cybersecurity cybersecurity and physical security to minimize those threats and risk as well. So just an overview of the converged Plantwide Ethernet architectures. As I said, there's over 15 of them that have been produced through this alliance, and all of them have been tested and validated. So these are just some of the top ones. SIP security, converged Plantwide Ethernet using NAT, identity and mobility, and implementing an industrialized demilitarized zone, or IDMZ, CPWE with resiliency, CPWE with virtual private networks, CPWE with device level rings, DLR. So all of these are different ones that have been produced. And over on the right, you'll see where it has existing recently published, or the ones in blue, such as the PRP and the time sync. Those are recently tested and published diagrams and architectures that have been tested and validated. And then some of them are works in progress, which would be the CPWE with resiliency. So that one is supposed to be published and due out later this year. They're still doing some final validation on it. And then here are just a list of those different design guides and white papers, as I said, that are been tested, validated, and are proven to help. So here's just a list of them with the links of where you can actually look at design guides for implementation, and the white paper that goes into more in-depth technical knowledge on what to expect. And with that, I will be handing it over to Joe Boleski.
Hello. So as we move forward, just a reminder, you can ask questions in the chat, and we'll do our best to respond to those. So a couple of the key tenets on the CPWE architectures. Next slide, please. So we really kind of focus a lot on the CPWE with a lot of the new security pieces, and it's one of the main driving factors when we start talking about bringing the IT and OT space together. Is one of the main things that comes up is typically security, managing who can get access to what, how they get access, how do we enforce security, and then also on the same side is uptime and data analysis and other reasons that we're trying to bring the two together so that we can see real time what the data is inside of our systems. And so with that, we have a couple different pieces, and because of Rockwell's partnership with Cisco, our Stratix switches are all Cisco based underneath the hood, which means all of the IT platform functions that work on Cisco products using command line and all of their tools work down into our switches on the OT side as well. And that allows us to do a bunch of different things about enforcing different policies and being able to set up different groups and control who has access to what. And it allows a bunch of different technology there where we can actually do some anomaly detection and things like that on the network. So very, very powerful being able to bring these together and being able to use the tools across both pieces. Next slide. So with that, we also have the capability of doing software-defined security groups and segmentation. So not only can we break things apart into different VLANs and things like that, where different parts of the network are isolated effectively, we still have the layer 3 technology allowing everything to talk together. So we can use some policies to say that this computer or this person can only talk to this device, or these devices can only talk to these other devices. So you see a role-based policy table there on the left that basically sets which devices can talk to what. And one of the important ones being, if you look on the furthest right, there's an EWS, which is in SGT30. It doesn't have permission to go out to STG 100 or SGT 100, which basically means that your engineering workstation is now isolated to just the plant floor. And so there's different things that you can do there where you can limit which devices can see which other devices. And this is very good for security purposes and being able to manage what's going on there. Next slide. So the next couple of slides, we're going to talk about some stuff that's new, so recently released, and stuff that Rockwell's working on. So one of the big ones is network security. So this was released in January of 2019 and goes into a lot of depth about the different security offerings, the way Rockwell is implementing security, and different pieces that go into how we want to lay out security. So you can see the links to the collateral there. And so we've released those, and Rockwell is continuing to stay on top of that. And it focuses a lot on the different network security use cases. So the difference between visibility identification, we want to do some of this security group policy segmentation, and how would you implement that? And then also network flow, threat detection, malware detection, those type of things. And then, management of remote users. And so how do people get access? So it talks a lot about different ways of getting in and out of the network and how you would manage people getting in and out of the network and the different identity services that exist within Rockwell and Cisco's offering. Next slide. So we have recently released phase 2, and I say recently, we've actually got something else coming up in a minute, of DLR. And basically this takes into account all of the switch level, device level ring functionality that has come out in the last couple of years. So Rockwell has done extensive testing on that in implementing device level ring with the switch level. And so these design guides are very good for allowing you to understand what the limitations are, what the use cases might be, and how you would implement these. And so with the Stratix 5400, we're actually able to do 1 gig device level rings. And we can also do multiple device level rings. So the 5400 is also capable of doing up to 3 different device level rings at the same time off of the switch. So that's the picture off to the right. And that gives you a lot of different scalability and flexibility within your plant to meet your uptime requirements, as well as your recovery time from a network interruption. Next slide. So we've also released one in May of 2019. It was the CPWD Time. And that one focuses on the IEEE 1588 precision time protocol. And within our world, we refer to that as SIP sync. And there's a lot of little pieces about 1588 that make it very, very useful, because we can get down into the sub-millisecond range of accuracy on setting clocks. Actually, it's down more toward the microseconds. And that allows us to have all of our devices so we understand first out faults and can track what's going where. And we use it extensively in stuff like motion. So our motion applications, it's really an enabling technology for doing motion over Ethernet. And there's a few little pieces that are very important when it comes to a plant-wide network in managing how that is propagated across the network to keep it consistent, so that you don't have variations in your time as it propagates across the network. So very important to be able to look at this reference guide and make your decision on how you're going to set up your switches and how you're going to set up your network on a higher level. So when you start getting up in near the layer 3, so that you have that flowing appropriately through your network in a controlled manner. Next slide. So we also have PRP, which we just talked about yesterday on our Tech Talk. And so there's a design guide that was released in November about that, talking about our different parallel redundancy protocol devices and going into detail on some of the things that work very well, some of the things that don't work very well, how to bring those and connect those to the enterprise level, and may still maintain a level of resiliency once you get outside of the PRP zone. So PRP is effectively, for those that don't know, two separate networks running the exact same data. So channel A, channel B. So in this case, you have LAN A and LAN B. Both of them have the exact same data on them effectively coming out of the controller. So the data coming out of the controller goes to both networks at the same time and moves out to all the devices on it. It is capable of having singly attached devices, as you can see with the HMIs that are only attached to one of the LANs. And we have red box devices to be able to connect in single port devices on, or the devices that do not support PRP natively onto that network. So a very useful network, and has a lot of, but it has a few little pieces that you need to know specific stuff about. And the design guides and the white paper are very, very useful for being able to implement one of those properly. Next. So cloud connectivity came out in January, and these design guides talk a lot about being able to get data in and out from the cell area zone level, so the bottom level of your network, all the way up into the cloud, and effective ways of doing that in a secure manner. So this covers a lot about getting information in and out. They've got a couple different reference architectures to actually put them together as bronze, silver, gold, and platinum based off of the level of infrastructure you have and how complicated your network currently is. And so they've got a bunch of different architectures in there for you to be able to look at to see how it would be best to get your data out to the cloud in a reliable manner, but also a secure manner. Next one. So this one is DLR phase 3. So if we were to go back a couple of slides, you'd see there's a subtle difference in the design guide where it went from revision C to revision D. And this one goes out in March, and this includes even more design detail. Again, we're adding more and more functionality within the device level ring, and including a lot more information about mixed devices, mixed switch level rings, and looking at a bunch of different architectures within those rings. So if you look at the middle picture, you'll see some switches on the device level ring, as well as some other devices directly on the ring, and looking at that combination. Where the previous one focused a little bit more on the picture to the left, which is mostly just switches in a ring. So this one takes advantage of a lot of those different functionalities and being able to extrapolate on that. And it also focuses on stuff like redundant gateways. So within DLR, we do have the capability of doing redundant gateway out of the system. And depending on how you set that up, we can have either very quick failover or very slow failover. And it goes into great detail about all the testing that Rockwell has done over what the failover times are. Next slide. So SIP security is out in April, and with that one, it says plan, so I don't know whether it's actually out or not. We'll have to double check. But basically, Rockwell has released a bunch of devices that support SIP security. So effectively, rolling TLS into the standard packet structure of our SIP communications. And this allows for both authentication and encryption of data between devices. So we can either just prove that the data is correct, or we can actually encrypt the data in case you want to make it anonymous. And it goes into a lot of detail about how these networks would be architected. There are some limitations on what devices can have it, what devices don't. We have a couple of devices coming out that support basically SIP security for hiding a device behind it in case you need to bring something into the secure zone or have something communicate across a secure zone. that doesn't support SIP security natively. And but it does include a bunch of information about all the different topologies and how you can have things work, as well as a policy manager. So how you would manage setting up SIP security, how you enable it, disable it, uh, harder to disable than enable, and getting it set up and working properly within your plant network. So very useful as part of the security rollout. And it does meet, and it takes into account all of the IEC 62443 codes. So that's one of the main things that they've been focusing on there, and with compliance to all of those requirements. Next slide. So a couple of the key takeaways that we have is, Rockwell and Cisco have been working together for quite a long time, well over 13 years. And they have a multiple set of architectures that they've tested and validated. And Rockwell does have a complete lab set up with multiple switches, a lot of network devices, and a lot of equipment there to test the different packet generation functionality and being able to test segment throughput and reconvergence times and things like that, so that if something was to fail, what would be the failover time, and how to set up your ring to fail over quickly, and what is the recovery time on a set of stack switches depending on a different type of technology you're using. Because those are the pieces that really matter to us in the OT space. So Rockwell has taken it on themselves to provide a lot of that testing and stuff so that we don't have to learn it out in the field. And so they've proven a lot of these architectures and have put together a lot of these different documents that we have listed above there previously that show all of the different pieces that we can do and include a lot of data, some of it aggregated, showing what the average recovery time was when you're using a fiber link versus a copper link and all of that. And with Rockwell's and Cisco, their collaboration, it also allows us to be able to collaborate across IT and OT because we have that shared technology with the Cisco enabled devices underneath to be able to use stuff like command line interface and the capabilities of programming the Cisco and updating the Cisco stuff from an IT side as well, but still giving us the OT side where we have our SIP capability of doing configuration through RS Logix 5000, Studio 5000, and being able to update and maintain those switches on the OT side, so we can manage from both directions. We've also expanded that with Panduit. So Panduit is a key partner in this and making everything that goes between, and all of the support devices, all of the connection devices, all of the fiber, and supplying all of the components that we need to be able to make a full network. Next slide. So one of the key takeaways is the reason that we do some of these modernizations is, the cost reduction, agility, risk reduction. So we look at the CPWE conversions in the networks basically to allow us to make our plants run faster, make our plants run more efficiently. We can be more agile to our demands from our customers. You can see the data that we need in real time to be able to make real-time decisions. And we can order parts and repair faster. We can reduce downtime. And at the same time, we can also make the plant more user-friendly so that we can see what's going on after hours remotely and do things like that, but still doing it in a secure manner and doing it in a way where we're not going to have issues with network uptime. We're not going to have instability within the network. So one of the key things to do that is Rockwell and Reynolds, we offer different assessment capabilities to go out and help and understand what your network is and understand how to migrate to a network if you're running a different older network, a DH plus or something like that. How would we migrate that over to Ethernet when you do your next upgrade? And how would we bring all of those together? And then also looking at the architecture side. because there's two different ways that most people typically look at networks. The first one is I've got a bunch of stuff, let's hook it together. And the second one is, well, let's sit down for a second and draw this out and make sure that we're hooking it together in a logical way. And this allows us to be able to hook stuff with using all of these design guides, be able to sit down and look at how we want to put this equipment together, how we want it to talk, how we want to manage the network, and how we can make it scalable and usable in the future. And then we can also do our management of our secure devices. But the key thing here is that Rockwell has all of these documents that allow us to be able to support all of the different technologies and use cases for different networking layouts. Next slide. So I believe this is the last one, and kind of back where we started. So you can see the whole network architecture here. And the main thing that we want to look at is the CPWE goes all the way from the bottom to the top. And you know, a lot of times it's very easy to get to look at your zone or your area and say, I've got my controller and my IO and focus solely down there. But the CPWE allows us to be able to remember that this is much larger than than a simple skid sometimes, or our skid is going to be connected to a larger plant. Then how would that plant be architected? And how would we manage the uptime on that? And what different technologies would we use on different parts of the plant based off of the risk of downtime or the security required on certain parts of the plant versus other parts of the plant? And some of the different pieces, you know, in the process section, we may not need some of the precision time protocol functionality, but in the packaging section of the plant, it's very much needed because most of those will have servo drives in them. So understanding the different needs in the different parts of the plant are very, very important. And understanding that we have this level 3 and 3.5 where in the middle where we're looking at how the plant should be put together and architect. Where do we want to put our software? Where do we want to put our servers? How do we want to architect our server layer? And then how do we get from that, the data that we create there, how do we get that up to the enterprise level so that somebody sitting at their desk at the front of the building can look at some of the data that's being created on those servers? How do we get that through the DMZ so that we can keep the plant floor safe and secure, and also keep the noise from the plant floor from going out to the enterprise level? Because I'm pretty sure that your printer doesn't care about the SIP packets going between your controller and your IO. So managing that data, managing the throughput, and making a reliable, predictable network. So those are some of the key takeaways from today's talk about CPWE. And I'd like to, if you have any questions, please let me know. Looks like the SIP security one is out. I do see a note about that. It was released in May as planned. If you don't have any questions, I'd like to thank you all for attending today and hopefully see you tomorrow at users group. And we will talk to you later. Oh, I do have a question coming in. It's a very good question. Will we be doing a webinar about the IAB software? I think we will try to get one of those out there for you. That's a great idea, and I think we'll make that happen. Yes, specifically focusing on network architectures. All right.
There's another question that came in through the chat. Yes, user group. We're having a user group tomorrow about control logic's redundancy. Uh, our user groups are generally a little longer than our tech talks, so it'll go up. They go more in depth, more technical, and a little bit longer in length. So it's tomorrow morning, I believe at 10 a.m. We'll be starting our user group for control logic's redundancy.
Yes, now be focusing on the new functionalities, possibly L8 redundancy. So a lot of good things coming in that one.
All right. Don't see any other questions. Just want to thank you again for all of you attending, and we look forward to seeing you guys on some of our other user groups and tech talks that we have.